Hi viewers, you are welcome to today's tutorial. Today we'll be talking about a topic that has been given students problem. We are resolving vectors to the horizontal and vertical components. Firstly, let's start by defining vectors. What are vectors? Vectors are quantities that have both magnitude and direction. For example, we have the force, we have velocity, we have acceleration, they have magnitude, and they have a specific direction assigned to their motion or to their movement. Let's consider a force inclined at an angle theta to the horizontal. How can we resolve this force to the vertical component and the horizontal components? Quickly, let's look into that. We have the diagram of this statement is going to look like this. This is your vertical component, and this is your horizontal. And this is the force F inclined at angle theta to the horizontal. This is the horizontal component of the force, noted as Fx, and the vertical component of the force, noted as Fy. In order to resolve this force F to Fx, that means the value of this force, in order to know its value in the horizontal direction or in the vertical direction, some things have to be understood. When representing vectors, we can represent the vertical component here to have a right angle triangle. We can represent the horizontal component here in order to have a right angle triangle. So let me just quickly show you what I mean. This F of y and the vertical component of this force can also be represented here. And you are going to have still the same in magnitude and direction. So it's still going to be pointing upward. Therefore, in the long run, we are going to have this type of triangle. This is going to be a right angle triangle looking like this. This is the force. This is the horizontal component of the force, Fx, and this will be the vertical component of the force. Of course, our theta will be included. In the long run, we have a right angled triangle from the sketch above. Simply, we can use the knowledge of trigonometric ratio. The trigonometric ratio, we have sine, cosine, and tangent. We can use that to solve for the vertical component and the horizontal component of this force F. In solving to the vertical component, we are going to have the vertical component f of y. F of y is the vertical component. So, in order to resolve to the vertical component, we'll look at this right angle triangle here. We have our force, we have our angle, and we have the vertical component. From this triangle, we can say the opposite to the angle is f of y, which is what we are looking for. And we have the f, which is the force given. So we can say opposite over hypotenuse. The hypotenuse of this right angle triangle is this f here, which is the force itself. So we are going to use sine ratio in order to get the vertical component of the force. We have sine theta to be opposite divided by hypotenuse. Therefore, our sine theta is going to be, instead of writing opposite, you write the f of y divided by the f. Then we cross multiply. Once you cross multiply, f of y will be made the subject of the formula. Therefore, f of y is equals to f multiplied by sine theta. And finally, f of y, which is your vertical component of the force, is going to be equals to sine theta, f sine theta. How do we resolve to the horizontal component? We are still going the same way. Resolving to the horizontal component, we are resolving to the horizontal component. We have the force given already, and this is the horizontal component, our target, and we have the theta, which is the angle. We can use, this is the adjacent of the triangle, and this is the hypotenuse. The trigonometric ratio that has the adjacent and the hypotenuse is the cosine. So we are using cosine to solve this. Cosine ratio. Cosine theta is equal to adjacent divided by hypotenuse. Therefore, we have cos theta is equal to adjacent. Our adjacent is the f of x, what we want to calculate for, divided by the force. Then the next thing to do here is to cross multiply. Once you cross multiply, f of x will be made the subject of formula. F multiplied by cos theta, and this is going to become f of x is equal to, let me make it a subscript, f cos theta. Therefore, this is how to resolve vectors to the vertical and the horizontal component. It is very easy to understand when it is done gradually like this. But in most books, students see the horizontal component, f cos theta, the vertical component, f sin theta, and they are confused. But this is the step-by-step way of resolving it. Thank you very much. And this can be done practically when you assume you can assume your theta to be angle to be 30 degrees and probably the force to be 10 newtons. What you just have to do to get the vertical component and the horizontal component is, assuming your force is 10 and the angle is 30, just substitute 10 for F here and substitute 30 for theta in the formula here and do the calculation. The value of the force in the vertical direction will be given. And the same thing can be done here. If you substitute 10 for F here and substitute 30 for theta here and do the calculation, the value of the horizontal component of the force will also be gotten. Thank you very much. Always stay tuned to get more information, more explanations about physics complexity, and at the same time subscribe to my channel in order to get notification about new lessons. Thank you very much. God bless.